Section 3.3, multiplying two brackets together, nothing new, but it is grade B, so here we go. Question 1a, let's do a basic one, says x plus 3 multiplied by x plus 7. Essentially we're saying x times this bracket followed by 3 times this bracket. So we're going to get 4 terms. So x times x, x squared, x times 7 plus 7x. Now the bottom bit's just change colour. 3 times x plus 3x's. 3 times 7 plus 21. Altogether, just get the answer. Right, I've got x squared. Now we can simplify the 7x and 3x because we're collecting like terms. That's 10x. And of course plus 21 at the end. Doesn't show up too good, does it? Let's just stick to yellow. Let's just do one more involving minuses. So go p minus 3 multiplied by p minus 5. I'm going to speed up. P times p, p squared. P times 5 is 5p, but it's negative, it says so. Minus 3 times p, well that's going to be minus 3p's. And minus 3 times minus 5 is plus 15. Altogether, p squared stands alone. These two things are like terms because they're p's and they're not p squareds. Minus 5, then take away another 3 is minus 8p's, and plus 15 is an independent term, and that's it. I don't know, let's do I. I is here, cracking these little guy. I've got 5t minus 1 multiplied with 2t minus 3. Right, 5t and 2t, what's that? 10t squared. 5t times 3 minus 15t, because the minus there. Minus 1 times 2t. 2t is minus 2t. Minus 1 times minus 3 is plus 3. Squishing up, that's code for simplifying. 10t squareds. These are like terms. Minus 15, take away another 2. That's minus 17t's. And then you add the 3 at the end. That's that. I'll do the last one because it says this, and I'll do it up here. It says 3c plus 5 and the whole thing is squared. That means you go 3c plus 5 multiplied by himself. That's what squared means. Now it's easy. 3c and 3c, 9c squared. 3c and 5, 15c's. 5 and 3c, another 15c's. And 5 and 5 multiplied make 25. Squishing up, we go 9c square. There's 30c's there, plus the 25. Finished. Simple, juicy. Turn over the page. Question 2. Write an expression for the area of each of these polygons. Well, rectangles are boring. Let's just do one of them. I'll do the last one. I've got one of these little rectangles looking at me like that. That says 3 minus x, and this says 5 minus x. So to find the area, I've got to multiply that and that. So here I go then. 3 minus x with 5 minus x. Multiplying. 3 5's 15. 3 times x is 3x. Watch out, it's negative. X times 5 is 5x. Watch out, it's negative. And x times x is x squared. Negative multiplied by negative is positive. Altogether, I've got 15. That comes to minus 8x's plus x squared. Put it in a more stylish way. You put the highest power first, x squared, then minus 8x, and then the number at the end, and it's a positive 15. Alright, that's that one done. I'm allowed to use a calculator for these, but I won't. I think I'll do f. Now, f is a trapezium, and it looks like that. I've got to work out the area of a trapezium, but I'm playing with algebra here in the context of shapes, hence geometry. So I've got 2m and 3, the corresponding, sorry, not the corresponding sides, the two sides which are in fact parallel, as it wouldn't be a trapezium, and the height is 3m plus 1. Now you may recall the area of the trapezium is going to be that plus that, yeah, the a and the b, multiplied by the height and then divided by 2. So let's just work out the first bit, worry about halving in a minute. So I'm not going to write the word area here because I'm not going to work it out in one step. I'm going to go 3m plus 1 multiplied by 2m plus 3. That's not the area, that's double the area, because remember the trapezium, it's half a plus b divided multiplied by the height. So let's just do this bit first. So 6m squared, 9 m's, u and u, arrow, another 2 m's, and u and u. 1 times 3 is 3. Simplifying. 6m squared, 9 plus 2 is 11, plus 11m plus 3. Now the area of the trapezium is going to be half of that. So that will give me 3m squared plus 5.5 m's plus 1.5. Alright, let's have a quick check on that. Make sure I've copied it all right. Where are you? So it's going to be u with u, so height times that plus that, then you halve it. Yeah, not a problem, done. So that's that. I'm happy with that. Do a triangle now. I think I'll do J or I, H-I, I'll do I. Do it up here. I've got a triangle like this. It looks like a triangle, surprisingly. The height is 4t minus 3, and the base is going to be 3 minus t. You know, area of a triangle, half base times height. I'm going to work out base times height first and then just halve it. So I'm not going to write the word area until I'm actually going to work out the area. But first of all, 4t minus 3 with 3 minus t. No space for arrows. That times that. 12t, that times that. Minus 4t squared. That times that. Oops, not plus. minus 9. 3 times t is 3t, and it's positive because a minus times a minus. Right, what have I got here? Bloody blah. I have got, right, 12t plus 3t. That gives me 15 t's. Then it's minus 4t squared and minus 9. I now need to divide by 2, so I'm going to write the word area here. That's going to give me minus 2t squared. I'm putting the higher power first. Divide that by 2, plus 7.5 times t, minus 4.5. Okay, because half of 9 is 4.5. And that is the area of that triangle just there. One more. I'm going to work out the area of a square of side. It's boring. They didn't really draw me a square. Anyway, the side is 3b plus 7. So guess what? That's also 3b plus 7. Okay, make it look like a 7. No, rub it out, do it nicely. 3b plus 7. And because they didn't draw me a square, I'm supposed to get scared of that. Well, I'm not going to do that. I'm just going to work out the area. Here I go. 3b plus 7 multiplied by himself because it's a perfect square, because it is a square. That times that, 9b squared. That times that. That's going to give me 21b's. That times that, another 21b's. And that times that, 49. Simplifying, 9b squared, 42b's, 49. Problem solved, job done. What's on the other side? Too much to read. Expand and simplify. Oh, lovely. Okay, let's just do one of these things with double brackets. And grade B, worth doing it though. Just turn over and do it. I'll do the first one. No, I'll do the second one. It looks more challenging. It says here y minus 3 multiplied by y plus 1. Then I've got to add on y minus 2 multiplied by y plus 3. Now, big danger. I'm going to get 8 terms along here. Now, it's great while it's plus. If that was a minus, there has to be another trick employed to do that without making a mistake. So I'll do 4a2 and 4a3 together. Right, busting this open. Y squared plus y minus 3y minus 3. He's happy. Then add on y squared plus 3y minus 2y minus 6. Now, y squared plus y squared. So what have I got? I've got 2y squared. y take away y. Y take away 3y is minus 2. I'll tell you what, I've seen something, look. I've got minus 3y plus 3y. Let's just get rid of them now, shall we? So I'm left with y minus 2y will just be a minus y, won't it? Because 1 minus 2 is minus 1, so minus y. Now we're going to do the numbers. I've got minus 3, minus 6, altogether minus 9. That's my answer. I'll do the next one as well because I said I would. Working over here now. It says t plus 4 multiplied by t minus 3, and then take away t plus 3 multiplied by t minus 4. Now this is dangerous. This is not a problem going forward in the left to right direction, but then, it's going to get really dangerous. I'm now going to put a great big square bracket around that so you don't get scared. Let's just multiply this out in the normal way. T square minus 3t plus 4t, not tt, 4t minus 12. Then we're going to subtract the answer I get to this when I multiply out these two brackets. T squared minus 4t plus 3t minus 12. Okay, let's simplify this part to make it less scary. T squared minus 3 plus 4 is plus a single t minus 12. And now I'm going to subtract. Let's simplify this side. T squared minus 4 plus 3 is minus a single t, and we've got the minus 12 there. Now, can't simplify any further, so let's just write it out. T squared plus t minus 12. Now, minus t squared. Minus t means plus t, because I'm saying I'm subtracting minus 1 of the entire bracket. So minus 1 times t squared minus t squared. Minus 1 times minus t plus t. Minus 1 times minus 12 plus 12. Now look at this horrific little thing here. What have I got? All these are equal, by the way, because I've not made any mistake, I don't think. T squared take away t squared. Let's just cancel that to show that it's gone bye-byes. T squared take away t squared has gone. What's minus 12 plus 12? 0. That's gone too. I'm left with t plus t. Answer 2t, and that's absolutely beautiful. I'm going to do question 5 because it's like a mini proof, and I'll turn over and do that one. So question 5 says this: any odd number can be written as 2n plus 1. Let's just decode that. If n is positive, if n is an even number, 2 times an even number is an even number. Then when you add on 1 onto it, it becomes odd. Alright? Now if n is odd, if you double an odd number, it becomes even. Then you go and add on 1, it becomes odd again. So this takes care of an expression representing an odd number, because whether n is odd or even originally, you end up being an odd number if you plug it into this expression. So an odd number can be written like this. So that's odd. Show that the product of two odd numbers is always odd. Okay, well if that's an odd number, and another odd number is going to be 2n plus 1 as well, n's going to be different. Number ways have shown this. I'm going to say 2n plus 3 is also odd. Is that okay? Because if that's an odd number and I add on 2 more, I've gone over the even number and become odd again. So product means multiply. So I want to multiply these two expressions and see what I get. 2n times 2n is 4n squared. 2n times 3, 6n. 1 times 2n is 2n. And 1 times 3 is going to be 3. So that's going to be 4n squared plus 8n plus 3. So let's just take a look. 4n squared is going to be even. 8n is going to be even, because if n for example is odd and I multiply by an even number, it becomes even anyway. So, and then I've got at the end of it plus 3 equals odd. Therefore the number will always be odd. Is that okay? Well, the product of the two odd numbers will always be odd. So product of two odd numbers will always be odd. And I proved it because I ended up with a 3 at the end there. So whatever you do, as soon as you add 3 to a number, you've become odd, haven't you? Because these two numbers added together make evens. That's that. 6 is horrific. I really fancy it, but the video's getting a bit long. I may do it as a separate standalone video so it doesn't become too much. So I'll pause that now and get back to you just for questions.